How are you doing today? You're welcome to class 6 for the Python for Data Science program. I hope you've all been having a nice time. All right, so would get started quickly. Today we'll be looking at Pandas package. That's what we'll be looking at today, and it's a very interesting package. Just like NumPy was last class we talked about NumPy, numerical Python package, but this time around we'll be starting off with the Pandas package for data manipulation and data analysis. Okay, I'm trying to get some people to I'm trying to get some people admitted. Okay, let's get started. You're welcome once again. All right, so last class we looked at NumPy, and today we'll be starting off with Pandas. And I don't know if you were able to go through the assignments. I don't know if we're able to replicate the picture, the NumPy picture challenge. If you're able to try your hands on it too. If you were, you could just give me a thumbs up in the chat. Okay, so today we're looking at Pandas, introduction to Pandas, how to create Pandas data frames. We're looking at indexing, selection, filter, sort, and group by joining and concatenation. All right, so that's what we hope to cover today. The notebooks are in on the LMS, so you can access it on the LMS. All right. So Pandas is a data manipulation package in Python, and it's very, very robust because it's used to do some sort of data manipulation. And when I talk about data manipulation, what I mean is having to maybe if you have data with different formats, maybe Excel data from Excel, data from CSV in CSV format, JSON format, HTML format, and so many other formats like that. Pandas would be able to help you manipulate it. So we'll be learning the basics just like we do. We'll start from the building blocks of how to use the Pandas library and the different ways of, first of all, creating a Pandas library and how do you do your importation. Maybe you want to work with an external file. How do you work with an external file before we start talking about manipulating our data sets? All right. So as a data scientist or a data analyst, if you are faced with maybe a data analysis task and you have to use programming for it, not all data analysis tasks involve using Python. We have so many data analysis tools like Excel, could use SQL, you could use Tableau, Power BI, and other packages. But each of those application or packages, they have their different functions. Like Power BI and Tableau, it's good for data visualization. Maybe you want to do data storytelling. All right, so those tools are very good when it comes to that. But when you want to do maybe as a data scientist, before you even talk about building machine learning models, you have to first of all do some data analysis. And Python is a very good package that would help you perform that function of data analysis, because it's going to it has lots of libraries that you can use to manipulate your data. And the data analysis pathway, when we get to Power BI, data analysis with Power BI, I'll take you through some of the data analysis process. There's a place of data collection where you have to gather your data, and then there's a place of you doing your data cleaning. I haven't gathered your data. There are different ways of gathering your data and all of that. But then I want to focus on data analysis with Python, because your Python package has several functions and the methods used in analyzing your data sets. Okay, so like we talked about data structures in Python, Python Pandas is used for manipulating numerical data. You could also use it for text data as well. All right, but most especially tabular data sets. When you are faced with tabular data sets or data sets in different file format, like maybe CSV and all of that, your Python library can manipulate such data. And when you have tabular, for people that are new to data analysis, right? Why do you actually do data analysis? You do data analysis because you want to, when you are faced with a raw data set, like for example, a sales data, maybe let me use Amazon, for example. Amazon has over time, they have several sales that they've done for different years, different states, different customers, right? So all the data goes somewhere. Maybe it might be in a database or maybe their data storage where they store their data. But the beauty about data analysis is that as a data analyst, you can take those raw data sets and start investigating, start doing using some tools like Python Pandas. You can start analyzing those data, investigating, finding out insight, trying to gain insight from that data. You want to find out so many relationships that on the Excel or the spreadsheets, it will not tell you exactly what those things mean. All right. So that's part of the beauty of data analysis. So in the process of you analyzing a sales data, you begin to see the buying pattern of some particular set of customers. Maybe Amazon might now discover that, oh, in Nigeria, people usually buy clothes more, or at so time of the year. Maybe as a data analyst was the one that found out that in the process of analyzing their data set. So the person, you're able to tell a story with that data based on some of the tools that you're going to be learning now. So you're able to give informed decision to your client or to your maybe if you're working with a company, to the business executives, and you're able to tell them that, okay, within your data set, these are the things I found out, and then they are able to adjust their maybe advertisements. Maybe they could just do more targeted ads towards the sales of clothes to people in Nigeria, because they have observed that at also time of the year, people in Nigeria buy this particular item. And so let us target more ads to that. Make more targeted sales to those particular people. And that's how they make more profit. It increases their yield. So that's the power of data analysis. All right. So enough of the theoretical concept and background. Let's get into how to use the Pandas package. Okay, like we usually do, I'm going to train for 30 minutes, and then we'll do, okay. Let's just go right into it. Then I'll take questions. I want this session to be more interactive. Sorry, can you all see my screen? Okay, all right. So let us proceed. Okay, so when you are faced with a tabular data, like an Excel spread, let me see if I have, okay, we all know Excel, right? Are we all familiar with Excel? The Excel spreadsheet, Google Sheets, and all of those kind of sheets. We are familiar with that. So when you see an Excel sheet, right, your rows and columns, they mean different things. Just like from what we've been talking about, the rows represents an observation and your column represents their features. That's the inputs on your spreadsheet, your features. For example, you have a Google form that's asking for first name, last name, phone number. First name, last name, phone number will be where? On the columns. They'll be on the, let me just show you a sample of a table. Now, for example, you have this small table, you have the name, age, number, and of cars and grade. So these columns are what? They are your features. And then each individual rows are your observations, that is unique records of people, or could be record of a good service sold, or whatever record that you are storing. Okay, so have that basic understanding about tabular data. All right, and then there are different data types that Pandas recognizes. Pandas, you can store different type of data in a Pandas data frame. You could store your string with our foundation of data types, right? We know about our strings, our floating point numbers, Boolean. You could also have your text values, date time values as well. You could have all those type of data types on your table. Now, before you use the Pandas package rather, you have to pip install it, just like we did for NumPy. So you have to pip install your Pandas data. Sorry, you have to pip install your Pandas data using your Anaconda. So you just pull up your Anaconda navigator if Pandas have not been installed. So to know if Pandas have not been installed, you could just do import Pandas as PD and run that cell. If it shows an error, like an importation error, maybe module not found. Okay, mine has been installed, and that's why you're not seeing any error. But if it shows an error, you just go to your search bar. Let me see if I can, share my screen. Okay, just a minute. Let me share my screen. I'm trying to admit people as well. Okay. All right, so I'm sharing my screen. So what you do is you can just pull up another Anaconda prompt. And when you do that, you could pip install, just say pip install Pandas. So you just put enter and then the installation begins. I have it already installed, so I wouldn't need to do that anymore. So that's just a simple way to install it and everything would go well. So once the installation is done, you can now continue with your import statements. All right. So after importing your libraries, there are different ways to create a Pandas data frame. I will be looking at that shortly. Let me just try to pull up my page. All right, so we have different ways to create a pandas data frame. We can use the list. If we've talked about lists, right? Using the list of lists, you can use a dictionary, numpy arrays, pandas series, and tuples. I'll be showing you the different ways of creating the pandas data frame. So now, given these lists, like we know we are familiar with list, right? A list is just a kind of data structure that holds different objects. It can hold integer, floating point numbers, and booleans, and all of that variable data types, right? So this is a list inside another bigger list. This is lists. List 1, list 2, and list 3 inside this data list. And after initializing this, so for example, you want to create a table of 3 records. So this list 1 is your record 1, list 2, Imral record 2, and Chooks record 3. All right. So having this list of lists, there is this function called data frame. So to create a data frame from a list, you could just do PD, that's pandas. You know, we initialized our pandas. We had to import pandas as PD. So importing pandas package or importing the full package. So there are several other functions or modules that you can use in the pandas package. And one of them is called the data frame. You can take note of the spelling of the data frame, capital letter D and capital letter F. So when you do PD.data frame, it takes the first input. If you do shift enter, you see the syntax. The first input is data. That is what is the data you want to convert. This list, you want to convert it into a tabular data. A data frame is just like a way of presenting or preserving a table in Python. It's when you have a list, a tuple dictionary, you can convert it to a table using the data frame function. So when it takes the data that is the list of lists that you want to convert now, and then one of the arguments that it takes as well is the columns. The columns, that you want to set the column name that is the first column here is IO, and that's a name, comma. You're giving the list of columns in a list, the names of the columns in a list. So the first column is name, the second one is age, the third one is number of cars, and the fourth one is grade. So this is just like you're just creating your own table from scratch. I'll just keep showing you the different ways to create a data frame, right? You might not have to create a table from scratch. You might have to import it from somewhere else. So we'll also talk about that. But then there are times that you might need to create a table or from scratch, or you have a table in a list of lists or a dictionary and want to convert it to a data frame. So this is how to do it. So having defined the column names, you just pass it into the variable name, any variable name called that you can define, and then you print it. And when you print it, you see that you have your record now in a data frame. So that's the first way to create a data frame using your list of lists. You can also create a data frame using, now I won't be doing some selection here because I'll still go over selection. So I'll just go right into creating data frames so that we focus on what we have to do. All right, we can also create a data frame using our dictionaries. You remember how to create a dictionary, right? When you want to create a dictionary, you have what? For example, new equals, you have this, your dictionary format, and then you have your key. So when you are creating a dictionary, you have your key, right? The key is here is a name. You see that the list, the way it holds this data is different. The key here is the name of the column. All right, so you can have your name. Okay, let me use BMI, for example. You could have your height, your height in as the key, and then you can have heights of maybe like 4 persons. Sorry, that is too much. We have like 1.68, maybe 1.52, 1.3, 1.2, and then you have comma, right? The next, you can create another row called the weights. I'm trying to create a table of maybe the BMI, the height and weight of a particular of some persons, right? So you have the weight as maybe 50, 20 kg. You have let me leave it in 20. You have 50. You have 30. You have 78, 79. Then you can have maybe the name of the person name. You could have A, B. I'm just using that as a random name. C and D. All right. So okay, let's leave it at that. So this is a dictionary called new. So if you print out this dictionary, it's a dictionary. So you can convert it to a table by using your pd.dataframe. You could just say new table equals pd.dataframe in brackets the name of the dictionary called new. So because we automatically it reads the height, weight, and name as the columns because it's a dictionary. So it's already labeled the height, weight, and the name as the column. So when you run it, you can see that it can easily convert your dictionary to a table. So that's just a simple way of doing that. It's the same thing that was done here. This is another dictionary. Okay. So we have two people in the library and just try to admit them. All right, so haven't done that. Let's move to another example so that we can run through what we have for today. So we have another dictionary. This is another dictionary that holds the estate, capital, area, and population, and you can convert it into a data frame using the pd.dataframe, the name of the dictionary, and you can see all of the records. To check the data types, you can do df.dtypes, and that would give you the data types of each of the columns in the dictionary. So this will not be looking at all of this because I'll also talk about that later. Another way for creating a data frame, you could use a pandas data frame from lists using the zip. There's this method called function called zip. Here, the zip function, you can use it to zip two lists together. For example, you don't want to create a list of lists. You want to just zip the. For example, maybe you have first name and last name. You could just use your zip function to zip the two lists together. So you define maybe the first names of all the people that are involved. And here is the name and the age. You have the second list holding the age. So you could create a tuple called lists into brackets, zip the name and the age. And when you print this, let me print this so that you see what it looks like. All right, so okay, made a mistake somewhere. Okay, so this is the zipped list that we created. So having done this, you can now convert that to a data frame using the pd.dataframe, the name of the tuples, command the column names, and that gives you this particular table. All right, so those are ways we could use to create different data frames. You could also use a series, a Pandas series. A Pandas series is just a single column in a data frame. That's a Pandas series. So you could use a Pandas series to create your data frame as well. And it's just having instead of you having the maybe a list, you could just name it a Pandas series. You can put it in a dictionary format. The key would be the name of the column, and the series would be the lists that you want to hold in that particular column. So when you create a Pandas series for each of this item, if you can always pass it into the data frame function, and then you have your data frame. So I'm just taking you through all of these possibilities so that you would know that it's possible to create a data frame from all of these different file formats. All right, so let's just go straight down. Let's go into another way of creating data frame. This time around, maybe we have an external file, and we want to import that file. For example, you have a file in CSV format or in Excel format. Now, this is a CSV format. So if you want to create a file, you want to read a file from a CSV file. So let me open this particular file. This particular file is in a folder in the same directory called data. And the name of the file is 2006.csv. So when I go to that folder, this is the folder. This is the notebook I'm working on. So this is the data folder. When I open the data folder, this is the CSV file. When I open the CSV file, this is how it looks like. So to work with this kind of data, right, I can just come here and say pd.read_csv. That's the way to read the data set into a Pandas, into a table in Pandas. So it takes the file parts of that particular file. So here, the file is inside the data folder, right? So you have to write the name of the folder /2006 or so. That's the name of the file. So if the file is not in a data folder, maybe the file is just on the same level with this particular notebook, I don't need to include this data /. I don't need to include it. But because this is inside this data folder, that's why I'm including this data /. All right. Okay, so having done that, you can now read it, and then you see this raw file. Okay, you see how it's looking like. Now you're seeing it in a more, presentable tabular format. All right, so that's a way to read your CSV file. Now to the Excel file. So for Excel, there is this pd.read_Excel function, and this is just like the CSV, so it's similar. When you're reading your Excel file, the name of the Excel file, please take note of the extension. They're going to include the extension as well. The name of the Excel file, the extension in the name of the folder / the name of the file that you want to read. And then you read it with the pd.read_Excel, and you have your results. So, and that reads your Excel file. So if there are ways you could also read, there are several ways you could read different data sets in Python. You could also read from an HTML file. I won't go into the analysis of this data yet, so that we can just focus on the reading first, data input and output. That's what we're doing for now. And so that we can focus on what we have for today. So we also have HTML. Now, HTML can be very, very tricky because there are some HTML websites that they don't allow you to just read data from their sites. They have some security measures in place, right? So we have some scraping tools that you can use to scrape data from some of those sites. We are not talking about data collection in this module, in this bootcamp, so I won't be focusing on that. So there are different libraries. There's a library called Beautiful Soup. in Python, where you have to use the library to scrape data from different websites. Like some people scrape data from some stock websites and all of that. But web scraping sometimes it's very, very, very there are several regulations behind scraping data. So you have to be very careful. If you're not authorized to scrape data from a particular site, please don't. We have some sites with APIs, yeah, that allow you to easily connect to their API. Like there was a project I worked on, has to do with Marvel, this Marvel superheroes sites, data sets. So they have the data, their site supports you to gather data from the site. So you have you use API requests to gather data from their site. So these sites, I worked on some data sets on their site. So you can easily gather some. Maybe you need some, if you want to do a project that has to do with analysis of some superheroes, Infinity Wars, and all of that, right? There's an API to gather data from their site. So, but then basically, if you want to, for available sites, maybe there are sites that they don't really like this URL. Now, for example, it's open. You can easily pick up. Like I'm gonna open that URL now. This is the runnersworld.com. It has to do with the fastest runners in the world. There are some data stats regarding some of the marathon runners. So, for example, you want to get these tables from these sites. Maybe you need to do some analysis and you want to get out those records from the site. I'm going to show you how to get out some of this. You can see these records now. So if you have to do this manually, it will take you a lot of time to start typing, or maybe you first of all do copy and paste to Excel, you clean the data, and some of all those things. So, but with Python, it just takes like 2 or 3 lines of code, and you get out your data. You don't have to stress yourself, right? So I'm going to show you how to get data from sites like this. Okay, read one. If you have questions, please drop it in the chat. I'll be looking at the questions. Okay, you can't see my screen. Can you all see my screen, please? I'm just seeing the message. Can you all see my screen? All right, great. So I want to be sure that we are all seeing the screen so that I don't I'm not just talking to myself. All right. So now for this particular website, it was just easy to get out data from, to retrieve the table. So let me just go back to my record. So the first thing is you get out the URL of the sites that you want to retrieve the data set from. Then I haven't gotten out the URL. There's this pd.read_html format that you have to use. Like, if you want to read from a CSV file, you use read_CSV. If you want to read from Excel, you use read_Excel. You want to read from a data, maybe you want to create a data frame, is what pd.what data frame. But for HTML, you have read_HTML, the URL that you want to read. Then we are setting the header to 0. That is, you're telling them that, okay, the first column is the header. So that's the essence of this header equals 0. So when you do this, let me just comment this out. And let's print out our table, CML table. Okay, said URL not defined. So there's a mistake with my L here. Okay, so you can see that it got out all the tables from, it's not very fine here, right? But then you can, if you look through your the website, the very first table, let's go to the very first table that we can see here, is Kelvin, right? Kelvin from Kenya. So let's go back. You can see Kelvin from Kenya as the first person. He finished in 2 hours, and and the marathon was Chicago 2023. All right, so this tells you that you've gathered all of the tables. Now, for you to check the length, you can do the length of the tables. On this website, they're about let me find out the number of tables. But if you do the length of the tables, let me just uncomment this particular place. So the type of the table helps you it tells you the type. That is, what's the type of the table. It tells you that it's a list. When it picked out that read underscore HTML gathered all those tables in a list format, and then the size of the table is 8. If you count the number of tables here on this website, there are 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so that's all the table we have here. So there are 8 tables. So you're very sure that you've gathered all the table on this list. So now, because it's a list, that tells you something, right? It tells you that you can index out the table one after the other using your list indexing. Can you see how you're connecting what you've been learning for what you've been learning over time and how you can implement it? Now, with your understanding of lists, the table where you print out this particular, let me print out the HTML tables again. So when you print out the tables, you can see they are not very, very explicit here. They are not clear. So, but because it's telling you that it's a list, so that tells you that you can index out them, and then it says that the list has how many tables. The list has how many elements? It has 8 elements. So you can index out the tables one after the other using your list indexing. So you can say the name of the list 0. You can see that you've gotten out the first table. This is the first table. Now, when you come back here, this is the first table on this website. Kelvin, Hilliard, I can't pronounce the names, I'm sorry. All right, so we have this first table here. How many people? About 6, 7, 8, 9, 10. 10 persons here. If you come here, you can see that this is correct, right? That's the first table. So if you want the second table as well, you use your list indexing for the second table. This is the second table. The third, there's a third table till you get to the last table. So if you want all of these tables, right, in your spreadsheet or anything, you can start saving them. The first HTML table, you can just give it another name and save it as first, maybe first record or something. You have the first record saved as in 0, second record saved in 1, something like this, right? Like that until you get to the 8th record. You can just save all of those first record, second record, like that, all into that particular variable. All right, and you can always use them. You can do your manipulations or anything you want to do with those information. Okay, so you can see the relevance of creating your data frames. Okay, so haven't stored those records, haven't stored them in a variable. You can also save them. Like maybe you want to output them. You want to download those records on your own file. I mean, on your local directory. You want to download it to your system, right? You can easily download those records. I haven't saved them for example, I've saved first record and second records, right, into this variable name. There is this to PDF to CSV function. This is you can use data to CSV. That is the name of the record. Like the name of the record was first what? First rec. This is first rec, right? This is first rec. You can say first rec dot to. You can save it as a CSV file. Then into bracket, you can give it a name. Maybe you could write fastest runner 1 or something. Fastest runner 1. And when you load this file, it is already downloaded on your system. So let me go to this directory where I have my notebook on my system. So I should be looking out for fastest runner 1, right? .csv. So let me just come here. This is where I have the file. So let me look for fastest runner 1 here. You can see the file right here. Can you see the file? You can see that we have it on our system now, right? So that's just a simple way of data input and output. So we just covered these basics of data input and output. That is not exhaustive. In the in the LMS, I think linked up, there is this Python data input and output cheat sheets. I don't know if it's here. If it's not here, maybe I'll have to put it. There's a cheat sheet I linked here. Okay, this is it. You can easily download those cheat sheets, and then you can use it to check for some quick. It's from Elite Data Science. So there are some, if you want to import data, pd.read_csv, and all of this you can use. So I just touched on CSV, Excel. I didn't even touch on SQL, didn't touch on JSON, but it's pretty much the same way. And if for example I touched on DataFrame. So now the next step after data importing, after learning how to import, we want to go into data selection. This is what we're going to be doing now. So I want to show you how you do your selection of maybe how to start working with your data sets. So this cheat sheet is just going to give you all the functions, related functions, just now to know how do you use them, right? Okay, so let's just go right into that. At this point, if we have any questions, let me check if we have on the chat. Have any questions? Okay, all right. I think we are good. So let us just go right into the other ones. Sorry, I've opened a lot of, let me just close this. Okay, so they are further reading. If there are some links for further reading, you see them they are all in the notebook on the LMS. So you can see them as well. So let's go to Pandas indexing. Right. Now, just like we do with lists and data frames, right? We can also do our indexing in Pandas as well. Like, how do you do your selections? How do you select your different if you have a table? Now, I want to talk about how do you start working with your tabular data. For example, you want to start doing some basic exploration. So I'm just going to be using dummy, just for simplicity's sake, I'll be using some dummy, dummy records for simplicity's sake. But for next class, we'll be working with real data sets, like having to explore a real life data set, or maybe we might touch on it this class, real life data sets, and analyze the data and draw insight from the data, right? Okay, so let's just try to get as much as possible done now. Okay, so there are several ways of indexing a Pandas data frame, right? But one of the easiest way is using the square bracket, which we are very used to. So this is just creating a data frame. You can use your array to create a data frame as well. So here this is created a random integer, 20 random numbers from 1 to 20, right? Using your mp.random.randint. So I'm going to get an error because I didn't do my imports. All right, so then you can use your reshape function. You can see how everything we're learning is coming together. You can use your reshape function to reshape it into a 5x4. That is 5 rows and 4 columns, right? So when you use your reshape function to do that, then you're creating another you want to create another list, WXYZ, just to give it a column name. So what you're just doing is that you want to have a list called WXYZ. So now we are going to create a data frame with this array, giving new rand, that is this array. Then you're giving it indexes, and then you're giving it the column name. So when you run this, it's going to give you this table. Can you see that your array now has turned into a table? It's just that it doesn't have array, right? When I was saying column 1, row 1, row 2, row 3, you can see what it means now. Row 1, row 2, row 3, row 4, row 5, column 1, 2, 3, 4. It's also zero-based indexing. But then in Pandas, it's quite easy because you'll be using your indexing is based on the column name. So we're going to get to that. So after created this data frame, this is another one that was created using an array. All right. So for example, if we want to index out the first column, you want to index out the first column, how do you do that? To do that, you're going to use the data frame, the name of the data frame, just like, the way we do it, indexing in our list, the name of the data, but this time around, you're not using 0, 1, 2, 3. Because you're using the square bracket, you could just use df, then w, that's the name of the column, then it gets you out the first column in the data frame. For example, if this is a first name, maybe you want to get out the first name of everybody in this, for example, maybe it's a school, and then you want to get out the first name of everybody in this school. I have like 1 million records. You could just do the name of the data frame, the square brackets, then the first name, and then it gets out the name. Sorry, I have to load this from here. All right, so the name of the data frame and then W. For example, I want to get out Y. That's the column Y, the same thing. So you can see 0.9 and all of that. I want to get out column Z, the same thing. So there are two ways of retrieving values from a data frame. You could either use your square bracket or you could use your dot notation. It's the same thing. So either I say df square bracket Z, or I say df dot Z. Either way, it's going to give you the same answer. You can see it's the same thing. But the danger with these dots is that if you have a name, a data frame name that has space in between, like there are some names that, sometimes when you write your first name, maybe you want to index out something like you have like first name, it's going to throw an error because when you're using your dots, you're not using any quotes in between. You're not enclosing it in a quotes. So if you're using your dot notation, it's good for names that are either maybe they are joined together with an underscore, or they are just one singular name. So that's when you use your dots, because if you use it with a space, it's going to throw an error. So it's just safer to use it the square, because whether it has a space or not, you can just easily put your first name like this, and it's going to read it like that, without any error. All right, so just take note of that. I just thought to mention that. All right, so that's the way to retrieve. Now we talked about retrieving just a single column from the data frame. You can also create, apart from retrieving, you can create a new column. For example, you want to, maybe you have the scores of two particular people, and then maybe it's this Y is the score. Okay, for example, let me use this example. You have the continuous assessment test and you have the exam results, and you want to create another column that has the total, right, from a data frame. So I'm just using this case scenario. It's not here, right? But let's just think, I mean, let's just see it as because of time, I can't start recreating this, but let's just see Y as the continuous assessment test, and Z as the exam result. So you can, to create a new table, right, you could just say DF, that's the name of the data frame. So you can call it total, right, equals, you select dy, that is the name, the column you want to add together, the first one, dfy, whether you do .y or y, same thing. But I just like this because it's kind of safer for me. Then you plus df z, sorry. So when you do this, right, automatically it creates a new column called total. So let me do this, and we're going to run our df. Now, when I do this, it's not going to show me any result, but let me run my df again. You can see that we have a total. So it has added these two, there's two together to give us this new column. So Pandas is very, very easy to work with Pandas. Once you know how to use and manipulate your data, it's very, very easy to, work with Pandas. So we're going to talk about other selection and indexing now. We talked about like selecting a singular column, right? Now, what if you want to select more than one column? You want to select like 2 or 3. How do you do that? So we're going to look at that shortly. Okay. All right. So if you want to do that, you can use your selection, like maybe the selection, the list selection that we do. I mean, when we are doing it, let me print it out. For example, I want to select the maybe Y, Z, and total. I want to select Y, Z, and total. Y, Z, and total this is 0, 1, 2. So I can say I want that will be like 2 to the end. And that's okay. Sorry. This is selecting the row format. So usually this is a row-wise selection. If you want to do a row-wise selection, right? This will give you a row-wise selection. But if you want to do a column-wise selection, let me take it again so that we don't get confused. You want to select YX, WXY, right? You could just do double square W, comma X, comma Y. And that gives you the selection of the 3. You take note that it's double square. If you're selecting just a single column, you use a single square bracket. But what if you're selecting more than one? For example, you want to select W and X, use a double square column, and it selects the columns for you. But if you now want to access the rows, now the row-wise selection, that's when you use your we can use our indexing. So let's just take note of that. For example, this index is index 0 and 1. For example, I just want to select A and B, right? I could just say that's index 0 and 1. I could just say either 0 to 2, and then it gives me A and B rows. Do we get that? Now, this is our main data frame. So here, I just want to select A and B. So you could just do your 0 to 2 to select your A and B. Did we get that? Can we try selecting, what if we want to select, I'm trying to check if we have any, okay, all right. If you have any questions in the chat. Okay, if we want to do a selection for C and D, can we give me the C and D? How do we select C and D? C and D, row C and row D. How do we do the selection? Using this method. There are several ways of doing selection, but I don't want to confuse it. Let me just stick to one. There's this lock and eye lock, which would also look at, I think, let me see if we be looking. Okay, yeah, lock and eye lock for selecting the rows and the columns. So rows, yeah. So, but then let me show you all of, this simpler format first. So if you want to select C and D, what's the answer? C and D. Someone said 2 to 5. 2 to 5 is CDE. 0, 1, 2, 2, 3, 4 is C and D is where? Let me see the other. 2 to 4. So okay, some people said 2 to 3, some said 2 to 4, some said 2 to 4. Okay, so the answer is actually 2 to 4 because C is our location what? 2, right? That is correct. Now, because we want D is our location what? 3. But because we want these to be inclusive, we have to add 1 to it to make it 4. So that's 2 to 4. And that gives us C and D. All right, thank you. Now, what if we want to select X and Y? How do we select X and Y? How do you select X and Y? X and Y. Are we dropping any message? Okay. X and Y. X and Y. Can we remember? Okay. Chima got it. Chima got it. Oluwadami Fola. You need double square brackets. And then there is a comma in between. For Mandy, it's capital letter X and Y. So we have to take note of some of the syntax. Capital letter X and Y. Otabi, capital letter X and Y. Umaru got it. So for X and Y, right? It's just like what Chima and Umaru wrote. We have capital letter X, then comma, capital letter Y. Then let's take note that it's double square brackets, right? So that's our X and Y. So I think we are getting it right now, right? We are getting it now. So even if you want to do X, Y, and total, you just add total to this. Total. And you have your X, Y, and total. Do you understand? Okay, and then you take note that this is just a selection. You can always save it as another, maybe you can save it as maybe something like new. And then if you now want to do another selection with this particular data frame, you're working with something different entirely. So it's just like this is a subset of this bigger data frame. I believe you understand what I'm talking about. By the time we start working with real life examples, you would get what we are saying clearer. But it's just if you know how to do the basics now, it's easier to work with when you have a larger data set. All right, let's move on quickly. I think we got that part right. We would go into, thank you, Madam Ify. All right, we let's go to another one. So we've looked at accessing rows. So this is accessing row, accessing columns. Accessing columns, we do our column assessment like this, right? I said we can rename it so that we have a new table. You could have a new table, and then you can say, okay, in this new table, I want to access A and B. The first two rows, I can say 0 towards 2, and then it gives me A and B for this subset I have. So that's very, 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 easy to manipulate. Now, what if you want to ask, okay, we've done this. So if you have a key, for example, let me go back to this table that we're working with. Now you want to access an element, and then the name of the column is not there. For example, here you can see that there's nothing like A in this. Okay, there's nothing like let me use P now in this column name. No P here. So if you want to access it and you do DFP, it's going to tell you key error. So anytime you're seeing something like key error, it's saying that key error, that there's nothing called key P on this table. There's no column name called P, right? So that's, I just want you to take note of that error, because that error comes up a lot when you're working with pandas. So I think we've talked about this. Now, there is something else that I want us to look at. We've added sorry. We added the table called total, right? I mean, this total. What if you want to drop? We've talked about insertion, like adding a new record. Maybe either you're creating a new record, or you're doing an addition of the two records. Okay, let me add another record. You could say something like DF. Maybe I want to add another record, like grade. So first of all, you use the name of the record, and then you can now equate it to anything. Maybe I want to add everybody is having a grade of A, right? So I can do something like this. All right. A, sorry, you have to put it in colon. All right. So when I do DF again, you're going to see that there's a new column called grade, and then everybody has A. You can see it's still similar to like like adding, manipulating tables, just like you're equating it to what you want each of them to be. So if you now want them to have like maybe you want the first person to have grade A, second person to have grade B. Now you now start looking at how to combine your all your loops that we've learned before. So that's not what we are looking at now. So I don't want to complicate what I'm explaining. So I just want you to know that you can easily insert another table. So now what if you want to delete this column? Want to remove this column? How do you do that? So to remove a column, like this column that I've inserted before, how can I remove it? You could use, there's this df.drop, that is the name of the data frame.drop, right? In brackets, it takes the column name that I want to drop. Now I want to drop grade. That's the name of the column I want to drop. Now, because I'm dropping grade, and anytime you are dropping anything on the column, there's something called the axis. You set the axis equals 1, because I want to drop the things I'm dropping on the column. I set axis equals 1. If I'm dropping anything on the rule, I set axis equals 0. But here we're focusing on column, removal of columns, right? So if I'm dropping a single column, I use in brackets the name of the column, axis equals 1. Then there's another function called the in place function. So when I load it now, you can see that grade has been deleted. If I load the original table, you see that the grade is still there, right? So that's why we add, there's another argument we call in place. That is, you're telling it, okay, make it permanent even on the original table. Can you make that change I'm doing permanent? So you're going to set in place equals true. By default, it's false, right? Sometimes you just want to see a view of what you're dropping. Maybe you don't really want to drop it. You just want to see how it looks like when you drop it. So in that case, you might not have to include in place equals true. But if you want to make a permanent deletion, you have to set the in place equals true. And then when I set in place equals true, you can now see if I load my DF now, you can see that now on the original data frame, that is totally gone. You cannot find grade there anymore. So that's how to delete a column from there. So, but what if you want to delete more than one column? Maybe you want to delete like 2 columns together. This time around, you put them in a list. You could say, for example, I want to delete X and I want to delete. I'm not going to set in place equals true here because I'm still going to use this data frame. And I want to delete Y, right? It still axis equals 1 because we are working on columns. And then when you load it, you can see that your X and Y is gone, right? But if you load the original data frame, you see that it's not gone because I didn't set in place to be true. So when you do it again, you can see that it's not totally gone because I'm not making a permanent deletion. So I hope we get that explanation. All right, so moving forward, let's look at okay, I've explained in place, sort of removal done above, just removes the specified instances on the fly, not in place. Okay, I've talked about in place equals true and setting it equals, Now, how about we removing the rows? I mentioned if you want to remove columns, you set axis equals what? 1. But if you want to remove rows, you're going to set your axis equals 0. So the same way, df.drop, the index or all this A, B, C, D, they are the index name. So by default, it's always 0, 1, 2, 3. But because when we're creating this table, we already gave it an index name. It is A, B, C, D, E, right? So let me load my original data frame so that we can see what we want to delete. Okay, so when you look at this data frame, for example, I want to delete, I want to drop A from my data frame. We've talked about dropping columns, dropping rows. Sorry, dropping columns, right? Now we're talking about dropping rows. Now I want to drop E. So I just df.drop, then the index of my column, that's A, the index name, and then I'm going to set my axis equals what? 0. If I want a permanent deletion, I make in place equals true, but because I don't want it permanent, I just want you to see what it looks like. You can see that A is gone from our lists. All right, so that's how to drop your rows. Okay, so I hope you got that explanation. The same thing, if you want to drop more than one row, you can do your square brackets A, and you could do something like this, D. I'll drop A and D. When you do that, you can see that A and D is gone. All right, so that's how you do your dropping column names and row names. So at this point, I don't know if you have any questions. Do you have questions before we proceed further? I want to check the charts if we have questions. We didn't take our break because I thought we had so much to cover. I want us to do a project, and it's going to be a simple one. Maybe on Monday, I'll let you know the project. So the way this bootcamp is structured, we have three modules for the bootcamp. We have the data analysis with Python. We have Python for data science, rather. We have data analysis, Power BI, and machine learning basics. So for each of this course, we have projects that you have to do. So you can, for people that are rolling in the 3 modules, you can get to choose any project that you want to do. But for people that is just the module that they are enrolled in, they have to do the project for that mode, for that particular module. So that is the way is structured, and then the presentation will be at the last week of the bootcamp. So you have like some time to work on your projects. All right. Okay, so do we have any questions before we proceed? We just take a break for like a 2 minutes break. I'm not saying, let me see if we have any message on the chat. Do we have any questions, or we are clear? We are still clear for now. I'm not seeing any reaction yet. So let's just take 1 more minute break so that we share with stretch our legs. Then we'll come back because we didn't take a quiz break today. So all right, welcome back, everybody. So let us continue. Haven't learned all of this. I want to introduce us to lock and iLock. So we looked at the different ways of selection of rows. We looked at using the indexing, that is using your indexing format. So you can either include your iLock or your lock. I'm going to show you the difference, right? So now here, let me print out the original DF that I'll be working with. Okay, so normally if you want to you want to filter out just your, sorry, somebody's at the lobby again. I think a lot of people are getting kicked out and we have to admit over and over again. Okay, so we have this original data frame. If you want to pick out, for example, B, for example, you know that you do DF what 1, right? Sorry, let me just. That was a mistake. Or went wrong? Did I load something else? Okay, okay, let's continue. I'm trying to check through if there was something wrong I did. Okay, so let's go to, this is where we were. Okay, DF. So our DF, okay. So okay, so here, when you're doing your selection, right, notice that when we're doing our selection and we're doing 0 to 3, we're indexing other parts. Like if you want to index the first three rows, the first, like if you want to index the ABC, that is what 0 to what 0, A is 0, B is 1, C is 2, that's 0 to what 3. It's going to work. But then when you're doing singular indexing, maybe you're doing, maybe you want to index out 3 now, you see that there is a problem. There's a problem with your indexing. It's telling you key error. Or you want to index out you want to index out your 4 now, for example, there's a problem. But if you want to index more than one, maybe you want to index CDE. CDE is what? A is 0, B is 1, C is what? 2. So that's like 2 to the end. You find out that it's working perfectly. So that's why the function lock and iLock came to play. So the lock function, what it does is that it helps you to index based on, or the iLock rather, index based on the index location. So I stands for index location. So instead of just the DF alone, you cannot have dots iLock. So it's still going to index out the same thing, but this it works better. So you can index for a singular, for example, the one at index 0 now that we're having errors with. You can see that index 0 now, you can index out everything on for 0. This is what 2.7, 0.6, 0.9, 0.5, and 1.4. If you want to index 1, that's the second one. That's 0.6, 0.3, 0.8, 0.6, and minus 0.24. So you can use your iLock to do that for selecting your index, the rows based on the index. But however, if you want to select it based on the name of the index, now there's a difference between the index position and the index name. So what you're seeing here, A, B, C, D, E, they are the index names. But by default, they come with most of your rows, they come with numbers, index numbers, right? If it's not given, if your index is not given, by default, Python sets it to 0, 1, 2, 3, 4. So if you have the index name, you can now use your lock to index based on the index name. So we're going to use that now. Let me show you how that is done. Sorry, let me admit. Okay. All right, so let's go back to how do we use our lock? We've touched on iLock. Now let's look at the lock now. Let me just add a new cell here. So we have our data frame. Now, for example, we want to index it based on your the position, that is the index name, not the index location. That's where you use your lock, df.lock. So for a singular, for example, you just want to index out your B, you can just say index lock B, and then it's going to give you your B. Now, if you want to index out B and C now, that's when you need your double brackets. I hope you're not confused with this lock and iLock. So for the the B and C, you use your double brackets with your .iloc. Take note that this is different from your columns. Here is the rows you're indexing out. All right, so just take note of those two differences. So I think that's basically it. For the other ones, now, if, for example, after indexing out your rows, you can now, if you want to specify the columns you want to see, you can further add another index of your column, that is your X. Maybe you want to index out your X and Z now. Columns, you can do this, and then it's going to give you just the X and the Z. So that's a way to, do your indexing with your loc and your iloc. All right. So we're going to move further to conditional selection because of our time. I want us to touch on filter and group by before we close today. Filter and group by, yeah. And then merge into as well. So let me go back to our conditional selection. All right. So haven't done the indexing, you understand how to index singular columns, singular rows, rows by indices, and maybe rows by index names. So rows by indices, use your iloc, rows by your index name, you use your loc. So that's the difference between the loc and the iloc. All right. So let's go to conditional selection. Sometimes you might want to do your selection based on a certain condition rather. Sometimes, like, maybe you want to do selection based on, for example, you have a sales data, and then under addition, you want to select all the numbers in your data sets that are greater than a particular percentage. You can use conditional selection to do that. So what you just do is the name of your data frame, then the condition. For example, in this old data frame, right? You can just say under addition. This is addition. Sorry, there's no key called addition. I'd already deleted addition. So let me print out the DF first. I'll see. Okay, there's under total. There's something called total. You can see there's a key error. That's key error is very, very. So you can say DF total. Then you can have, I want to have all the totals that are greater than 0 here. So it's going to, by default, it's going to return true, false, true, false. So you're going to have to enclose it with the full data frame name before it returns the exact value you're looking for. So I'm just showing you why this is being done like this. So you have this, and then you see that what all the ones that have the total greater than 0 has been filtered out for me. If you look at the original data frame, you see that this is it. So you can see that minus 0.2 and minus 0.0 is gone. So we just have ADE. So that's how to do like your conditional selection based on maybe either based on the entire data frame or based on a particular column, right? So you first of all select the column that you're referring. For example, if they say, okay, can you get out the maybe the total sales that or the clients that have their total sales greater than 10,000, right? So use the first thing that you have to think about is what is my column? What's the column of reference? Is the total sales, right? So you first of all highlight the total. Maybe there is a column name called total sales. So here, the column name total. So I first of all highlight the condition DF total greater than maybe 1,000. Then I'm going to enclose it in my data frame, that is the DF, and then it's going to get out all the clients with the totals greater than 0. So I hope we understand that. I hope that is clear. So that is the first way of selection. So there are different ways to select your data. So you could have greater than 1, greater than, these are just different ways. Okay, that this is another complex way. For example, even after doing your selection, right, you could do you could do your selection and then okay, so if you have another, maybe you're after doing your selection, you want to select based on a particular rule. For example, you're selecting all the numbers that are greater than 1 from your data set, from the entire data frame. You're selecting all the numbers greater than 1, right? You enclose it in the bigger data frame. All the numbers greater than 1, here you can see that it's just giving you the ones that are greater than 1. We have your 2.7 and all of this and all of this. For example, if you just want maybe just two of the rows, you can have another condition here now with your double square brackets. That's okay. Columns now. I want column W and column Z from my data frame, and then it returns that column for you. I don't know if you're getting this. You can see that if you want to select a double column, right? If you want to select more than one column, you use your double square brackets to do that. So we're going to see this when we are doing we're working on a real data set. We're going to see how to actually implement this with a real data set. Okay. So I just thought to mention that so you can do your selection based on conditions, and you can also filter out the columns that you want out from that particular data set. You can also do selections based on and or. For example, you want to join more than one condition together. Now, you can use your and or with parentheses. So you have this table, for example, and then you want to select all the elements where A is greater than 1 and B is less than 5. So automatically, where you have A greater than 1, that is 7 satisfies this condition, just this place, because when you look at this particular row, A greater than 1, we have 4 and 7. So this satisfies this condition, right? 4 and 7. But there's another condition that says A less than 1, rather. A less than 1 says DAF A less than 1. A less than 1 here is either here, okay, everything satisfies it. But now A greater than 5, this one strictly greater than 5, this one satisfies it. So this is the final result. I hope you understand the explanation. Let me take it again. Here, you want to select the condition where A is strictly less than 1. A strictly less than 1, that is A is 0 or negative. So here you have none of them satisfies it. Everyone is inclusive. But then there is an OR operation. So when you have an OR operation, so either of the condition is true. So there's this truth table that I would like to also bring to your notice, attention. For example, if you have an OR operation, it's not on this table. Let me just browse it out so that you can see the difference. Truth table. For and and OR. I'm looking for something that will be very simple for you to understand. For people with computer science background, this will be very familiar, mathematics, but for people that don't have computer science background, it might not be so familiar. So that's why I have to go over this. All right. So let me look at, okay, this would work. Now, we have the and, the or, So I'll just focus on the and the or. The and is just think of the and as the and operation. So I'm going to focus on this, the and operation. So when a condition is false and another condition is false, the answer, the outputs will be false. For example, you're saying that you have a data set and you're saying in that data set, you want the values that are less than 0 and the values that are greater than 5. Maybe if those two conditions are false, right, automatically your results will be false. But if on the hand table, if any of the condition is false, right, the answer will be false. But if both of the conditions are true, the answer will be true. So that's the way the and table works. So if any one is false, so long as any of the condition is false, the answer will be what? False. That is this 0 and 0, it will be 0, 0 and 1, 0, 1 and 0, 0. But anytime any of the condition is true, you have the answer as true. That's for the and. But when you're using your or operation and you have any of the condition false, I mean, both of the condition false would give you a false. Any of the condition false or true, it will give you a true. So that's for the or. Or is just like the reverse of the and. So I don't know if you understand the concept. I don't know if there are questions on the chat so that I'm able to look at the questions as well. Okay, so that's for the hand operation and the or operation. So now applying it to what we have here. So I think I might save this link and link it in the notebook on the notebook. I'll just save this image somewhere here. And then all. All right, so I'm going to link it for you with the markdown. I'll link it inside here. I'll upload it on the LMS. All right, so here now, given this particular table, let me just do my own so that it should be very, very clear. We have this DAF, and we want to say that on this table, I want all the values that are less than, where you have your A less than 1. So A less than 1, you can see that on each of the rows, they are all what? False. A less than 1, they are all false. So this is the first condition, right? So if you want to do selection for two conditions, so when you have the first condition, then the second condition is B greater than, let me print out the second condition first so that you're going to see it as well. Second condition, B greater than 5. All right. Now, B greater than 5, if you can see here, 2 is not greater than 5. So that is why it is false. 5 is not greater than 5 because it's strictly greater. That is why it's false. But 8 is greater than 5. So this is the only true we have here, right? Do you understand now? Right? So now, combining these two tables together with an or, false and false leads to what? False with our or gate. Let me just see if I can load that or this thing in the markdown. This, separate document. Oh, I have to start looking for where I saved it. Okay, because of our time, I might not be able to quickly do that so that we can I don't have it saved in this location, so I have to start looking for. So, but in our OR gate, if we bring up our truth table now, we can see that false, false is what? For OR now, false, false is what? False, right? False, true is what? True. True, false is what? True. True, true is what? True. So anywhere you see false, false is what? Is false. But in other places, they are what? True. So now let's apply it to what we have here. So you can see that false, false is what? False. So P will not be, P is already out of the option. False, false is also what? False. Q is out of the option, but false, true is what? True. So that's why it's displaying just R as your answer. Do you understand how we get, how we got to this answer now? So that's why you have your R as the answer, because these two, the truth table, based on the truth table, you can see that the answer is following that order. So if you want to do selections based on two conditions, you can either use your OR and your AND. So if I use my hand now, in this case, everything is going to return an empty table, because AND is a different, AND says that if anyone is false, then they are all false. That's condition for AND. All right, so that's why we are saying that it's telling you that none of the records satisfies this condition. That's why you're having an empty table. I believe we understand that explanation. So when we are applying to real world data, you see how this applies. Okay, so let's just move forward. Okay, let's talk about the multi-index and the index hierarchy. So there are ways that you can also have on a data frame, you can have more than two indices or index. You can have different levels of index. You could have your level one, like, we are familiar with that when we are working on Excel, right? Sometimes you have to combine two cells together just because you're having them in the same group, right? So you can also do that in Python, and you do that using your multi-index and the hierarchy index. So how do you do this? Now let's create a data frame, right? With this level, for example, this is the outer index and the inner index, right? The outer index is G1, 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 G2, 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 and the inner index is 1, 2, 3, just like what we have here. G1, G1, G2, 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 then 1, 2, 3, 1, 2, 3. Now, then you have your after you zip the two indices together using your zip function, and you have this. So now you could use your hierarchy index, right? When I load this is what we have. So we have our indices as this. All right. So now we can now say that can create a random number of a 6x2 matrix, so that we can have 6 rows and 2 columns. So now we can use our data frame, pd.dataframe index equals the hierarchy index, and then our columns A and B, and it's going to give us this. Okay, so because of what we have here, that's why we are doing this. So, but then there's another function called the pd.multi-index from tuples. So you can use it to create your hierarchy index and then your multi-index. And when you load it, it's going to give you your results of this, in an hierarchical format. So how do you do your selection? How do you index this in Python? Remember our lock. Now, this is where the lock and the iLock comes into place. The lock, when you're using your lock, you're indexing your table based on the location name, not the index number. When you're using iLock, you index based on what the index number. But because we have the location name here, the external, for example, you want to index just the external table, you could just do your df.lock, then the name of the external table, G1, and then it returns your G1 table. If you want to index inside G1, you want to index another column name, maybe a row in your G1, you can now use your lock as well, because it's still the name of the column. the name of the index. You could use your .loc again as well, and it gives you, maybe here you want to index out maybe column 1 here. So you can just do .loc 1, and then you're seeing that it's going to give you the output for 0.44 index 1, that is 1.0, and minus 1 0.15. So that's how to do your indexing for hierarchical formats. So because of our time, let me quickly go over this one. I want to go over filtering. Filtering is similar to what we've been doing, right? It's similar. So I think this is just more interactive in terms of they are more intuitive names than just saying numbers. So it's still similar to what we are doing. So I'm going to show you group by and sorting as well here. So given this data frame, the dictionary, right? We want to create a data frame called, we have company, person, and sales. The company, Google, Microsoft, Facebook, and then you have the persons and then the sales they've made. So based on what we've been discussing before now, we're going to talk about different things. We're going to talk about filtering. Filter helps to select a record from groups of record based on certain condition. What we've been doing before is filtering, right? We're selecting based on a certain condition, but then there are other levels. You can also group together rows based on some aggregate function, and you can also sort records whether in ascending or descending order. All right, so all of these skills we are learning is going to aggregate towards you maybe when you want to work on a bigger data set, you can now apply it together. On maybe you're working on a particular data set, you want to do some basic analysis, you want to investigate the data. Yeah, you can now apply all that you're learning together. All right, so let's just try to pay some attention to it. Okay, so when we have given this table, for example, we want to, based on what we've learned now, we want to get out the sales of people. We want to get out all the sales. The sales of a particular of the person that is equals to 340. Now, for example, here, how do you do that? You're just going to say DF sales, our condition first. What's the condition? Sales equals what? 340, right? That's the condition. And here is because this data set is very small. That's why it's easy, like to, you can pick it. Sometimes you can be working with 1 million records, or you can be working with 500,000 records. And you want to get out some information from that particular data set. How are you going to do? So it's still the same skills that you're using to do your filtering and all of that you can use as well. So here, for example, I want to get out all the sales that are equals to 340. Right? So the first thing is to write out the condition and then enclose the condition in the entire data frame. So it's when I do that, it's going to tell me that, okay, the person that has the sale equals to 340 is in Microsoft, Amy, and then the sale is equals to 340. So you can see all what we've been, doing and putting together, doing beforehand, and then we're putting them together. So what if you want to get the sales that greater than 100. Can we try that? What would be the answer? Greater than 100. Can we try that? I'm waiting. So what will be our output? What will be the syntax? Okay. All right. Thank you, Chima and Umar. All right. So DF sales said greater than what? 100. So let's do this. Greater than 100. You can see that it's giving us every persons that their sales are greater than what? 100. Everybody's sales is greater than 100. So if it's greater than 200 now, we can see that um this person's sale 340, 243, and 350. Those are the people that we have their sales. What if we want to filter out the records of retrieve all the company's record from Google? Can we try that? Retrieve all Google's record from this data frame. What will be the syntax? Okay, some persons are attempting retrieve all Google's record. So the first thing you have to take note of the condition. All right, let me see if there's any response. All right, thank you. Great. So what was written was DF. First of all, the first thing you need to do is, to state the condition. What are you trying to retrieve? The company. That's what you're trying to retrieve. Company equals what? Google. So we have to take note of the syntax as well. But then you need to enclose it in a square brackets, and then you have your DF. So okay, sorry, I made a mistake. I will company instead of company. All right, so you can see that you've retrieved all the records that are Google's. So you see that it still follows the same, thank you, Umar and Chima. Umar, don't forget to enclose your Google in quotes so that you're going to get the right answer. All right, so it's basically that's very, very easy. That's if once you know the basics, it's easier to, to easily retrieve as many data as possible. Now, you can also combine, we can combine different, just like we're combining our or and our or and hand here. So you can also combine two different conditions as well. For example, you want to retrieve all the records from Google and from Microsoft. So what did we say we should do? We're going to put them in a bracket. And what's our function for our and? And Microsoft DF company equals Microsoft MSFT. So now here is giving us a false because we don't have somebody having in the same company as Google and Microsoft. They are either in Google or Microsoft. So you can see the difference. So because there's nobody in Google and Microsoft together, Sam is just in Google, Charlie is in Google, Amy is in Microsoft, Vanessa is in Microsoft, Carl is in Facebook, and Sarah is in Facebook. So this and is returning an empty string. So, but if I put an or, because if any of those conditions is true, then the answer should be true, right? So, okay, this is also still giving me the different I'm coming, let me load this. Okay, it's also giving me a false. Said Google or Microsoft. So where's the challenge? DF company is equals to Google, or DF company is equals to Microsoft. I'm supposed to get a response because of the or. I'm trying to figure out where the error is. Is there any error? Oh, I can see my error now. My brackets is the error. So you can see that small error can cost me a lot of headache if I'm not really, paying so much attention. I was like, okay, I'm supposed to get Google and Microsoft together. I mean Google or Microsoft. So why am I not getting an answer? So that could be it's a very big major bug, and I'll be on it for like 2 hours, and I should get an answer. All right, so that's about that. You can use your conditions that we learned, either your and your or. If you use your and, you can see that it's going to give you an empty. But if it's or, because at least one person is either in Google or Microsoft, that's why we are having the both persons, the both companies need employees listed. So that's how to combine two different conditions. Now let's talk about the group by. The group by function, what it does is sometimes you might want to group based on a particular company, and then you want to perform the aggregate. Sometimes, for example, you want to find out what is the total sales of people in Google. What are their total sales? How do you perform that kind of operation? Total sales of all the employees in Google. So that's where your group by. So when you're talking about an aggregate, maybe you're looking at total sales, or you're talking about maximum sales, minimum sales, or have average. Like when you have to perform an aggregate over a particular group, then you have to use your group by function. So how do you use your group by function? Your group by function, this is how it works. The name of DataFrame dot group by, then what do you want to group by? You want to group by company, because we want to find out the company's total sale. So the company dot sum, the group by function originally cannot, it's just going to give you a pandas object. So you have to add an aggregate to it, either it's sum or an average or whatever aggregate. So here I want to see the total. When I do the sum, it's going to give me the aggregate of everybody's sales, whether in Facebook, in Google and Microsoft, right? So it's going to get me the total sales of everybody in these different companies. So if I want to get maybe the people in Google, I could just do my .log. You can see where the .log is coming into play now, GOOG, and then you have the sales of people, the persons in total sales of persons in Google. So here, that is how to use your group by function. You can also use it with the max. Maybe I want to see the maximum sale for the people in different companies. What are their maximum sales? Who has the maximum from here? Like if you have 1 million records, it's very difficult to tell. So if you have this and you have to say, okay, what can I find out the maximum sales in different companies? What are their maximum sales? So I can use my group by function, and then I can do DataFrame.group by the company.max. So it tells me that in Facebook, Sarah has the maximum, Google, Sam has the maximum, and Vanessa has the maximum in Microsoft. All right, so that is about the group by function. You can have, we have the sum, you can use the standard deviation, you can use any aggregates, minimum, maximum on, you can use the mean, you can use the median for your group by, and any of the aggregates. Now let's go to sorts. For example, when you're doing your sort now, you have to start copying so that you don't alter your original data frame. All right, so you want to sort this data frame based on maybe the company, that is whether in ascending or descending order. How do you do that? So use your sort values. There's this function called the sort values. So if I do df.sort value, by default, it's going to start from ascending order, that is F, G, A, B, C, A to Z. So the first one will be Facebook F, fcal, fcal is the lists as the first row, the first record with the lowest ascending order. We have the F, B, and C. F, B, and S comes next. Then what comes next after? We have the G and Charlie. Then G is Sam. Then M, Amy, M, Vanessa. So that should be the order. So when you do df new dot sort values, you have your results. fcal, F, Sarah, Google, Sam. But you can also distort the order by setting ascending to false. So by this, you can also you can sort based on person. Maybe you want to sort based on the name of the person, not the company now. And you want it to be in descending order. So by default, what name would come first in this particular data set? You want to sort in descending order based on person name. What name should come first by default? That should be very easy to pick out. We're sorting on descending order. It's Vanessa that should come first, right? Vanessa, good. Thank you, Vanessa. All right, so Vanessa should come first because it's in descending order. So we can have the other names follow alongside. So we have df.sort new person. It's even here. I didn't even know it was here. So when you do sort values, then the condition, that is the person, the column name, and then set ascending to false, you're able to sort in that order. Then you can also sort based off more than one column. Maybe you want to sort first based on the company, and then you want to sort next based on the person. So how does that work? So when you're doing, let me bring off the original data frame. Right? So if you are sorting based on company and person, so what happens? Company now first. So you first of all go to the company, you look for the is in ascending, descending, false. So this is more complex. So ascending true. You want to sort company in ascending order, and then you want to sort person in descending order. Sorry, you want to sort company in descending order, and then you want to sort person in ascending order. So company in descending order, the first company that comes first is what? Microsoft, right? And because you want Microsoft has two names, Microsoft Amy, Microsoft Vanessa. But because you want to sort person in descending in true, now a false is ascending order. You want to sort person in descending order. Sorry, it's a mix-up. Ascending true, that means you want to sort company in ascending order. Ascending false, you want to sort person in descending order. So company in ascending order, what comes first? Facebook comes first, right? And then we have Facebook Carl, Facebook Sarah. Carl and Sarah, which one comes first in descending order? Sarah comes first. So Facebook Sarah comes first, Facebook Carl comes next. So that, can you see how that would work? So you can see Facebook Sarah comes first, Facebook Carl comes next. Then it goes to the next order. That is the next company order, ascending order. The next company ascending order is what? Google. So now, but we have Google Sam, Google Charlie. Our condition for person is what's in descending order. So Google Sam comes first, Google Charlie comes next. So you can see Google Sam, Google Charlie. Next, Microsoft. Microsoft is in ascending. Person is in descending. So Microsoft Vanessa comes first, Microsoft Amy comes next, and that's why you have this. So it's a lot of logic going on in what you're doing here. But in analyzing your data sets, right, it's for you to just know the basics of what questions do I want to derive from my data. So that's when we are looking at our next class. We'll be walking through a real life example, and then we'll be looking at different questions that you can ask your data like you have a data sets imported from maybe Excel or a CSV file. It could be, we could look at Airbnb data, or we could look at employee salaries data. We could just pick a case study. Then you can now start looking at questions, likely questions that you can start asking. But you know, for you to answer those questions, you must know how to use some of this little filter, group by, sorts, and merge. We're still going to talk about merge, and all of that, joining, concatenation. Like if you have two tables, how do you join them together? On what condition, and all of that. So all these functions that you're learning would add up to how you're going to manipulate your data when you have a bigger data set, right? And you want to find out things about the data. You know, like I mentioned at the beginning, when the reason why you do data analytics is you want to get insight. There are so many things hidden in your data set that you might not really know by just looking at the data sets. Sorry, you might not really know by just looking at that data set. You can just but when you give it to a data analytics and analysis person, the person starts using Python or some data analytics tool to start investigating the data, finding out some key things about the data sets, you know, and giving insights, giving you possible insight about your data. And this is going to really help you making business decisions when it comes to maybe you have a business, for example, maybe you have let me use a sales, a supermarket, or you have an e-commerce platform. You want to know when to actually how to do targeted advertisement to some particular customers. You can download their the data sets, their buying and the spending pattern, give it to your data analysis team, and then they start researching. Okay, let us find out, when do people actually make these sales? I mean, make these purchases. At what time? What point? You know, by doing that, all of that, you're able to get some specific you're able to make some specific decisions based on people's buying and spending patterns. So that's part of what you do in data analysis. So when you're now talking about machine learning, you're moving a step further beyond just analyzing data. You want to do predictions. You want to do like predictive modeling. Like I've haven't understood that, okay, people actually buy something in a particular at a particular time of the year, but can you make prediction that using machine learning algorithms that in the next 3-4 months, this is what will happen, whether they will buy that particular product or not? So that's where machine learning comes in. Let me use another case study. Okay, for example, in aviation, because I know that there's someone in aviation on this call, in this training. In aviation, she wants to find out about the how when it comes to flight cancellations, and when it comes to when particular maybe a particular aircraft, maybe you want to do maintenance, when a particular aircraft is actually due for maintenance, or you want to predict whether there will be a cancellation or not. So you could have gathered several data sets when it comes to all the how each of those flights has been going, gather all the data sets and begin your analysis. Okay, what is the cause of the cancellations? What are the conditions? You know, by analyzing using Python, you'll be able to find out some key insight about the reasons for all of those cancellations. So when you're now applying machine learning algorithm, you're able to predict beforehand whether there will be a cancellation or not. You know, so beforehand, you're able to make so many decisions that, okay, because by my machine learning model is saying that, oh, this is likely to be a cancellation in 2 or 3 days and all of that, you're able to put all necessary things into place and, you know, make necessary decisions. And it's going to help you make some savings, you know, when it comes to having to plan your crew, rostering, and all of that. So that's part of the beauty of machine learning and data analytics. So it's applicable in any sector, in medicine, in finance, in sales, all over. Spatial data analysis when it comes to weather, so many sectors. So that's why it's just the knowledge. Once you're equipped with the right skill sets, you're able to, do so many things with different data sets and make informed decisions. All right, I think we've spent more than 5 minutes more than our time, and would have to come to a close. Thank you all so much. I don't know if there are any questions. I think, okay, sorry for the submission. I saw that somebody dropped a message that it couldn't make submissions. For the submission, if you go to the LMS, there is a link where you can upload under the recordings. You have links where you can submit your assignments, upload your assignments. So where you have the recording, there's a place where you can upload your assignments. So that's where you can just upload it there and we'll get it. All right. Thank you all so much for joining. We'll meet again tomorrow. Tomorrow there's going to be a mentorship session in the evening. It's just going to be for an hour. Please try as much as possible to join the session, and we'll get to talk and discuss more. Come with your questions. Yeah. Have a wonderful evening. Bye, everyone. Bye. Yeah.